Hello, and welcome to Office Hours with me, your naughty professor. I hope you don't mind I slipped into something a little bit more comfortable for today's lesson. I thought today we could keep going with some play with geometry, and I could show you how to find the area of a circle. Now, I'm not going to give you a rigorous proof that would require calculus, and I don't want to make any assumptions about what's going on in those lovely little heads of yours and how much you've learned in the past, but I thought it might be fun to see a picture proof to really understand what's going on here. Last time we saw that if I draw a circle, a radian is just, if I've got a unit circle, the angle that would go in here in order to get an arc length of 1. So if I straightened out this curve, you might notice I love doing that. Straightening out, stretching out my curves. If I straighten out this curve, I'm going to get a length of 1, the same length as the radius of this circle. And it turns out that if you measure all the way around, you get a distance of 2 pi. So what I'm going to do is I'm going to make a funky shape. I'm going to take a bunch of arcs of the circle and I'm going to put them together. Let's divide the circle in 4 pieces to start. So there we go, 4 chunks of a circle. So I've made a pie, and you know when you're trying to store pizza in the fridge and the shape of the container isn't quite the shape of the pizza, so you do that thing where you turn the slices around. So I'm going to play that game with you. So there's a quarter of the pizza, there's a quarter of the pizza, there's a quarter, and there's a quarter. Okay? Doesn't look like much yet, but we are starting to get this idea of a sort of parallelogram. Cool. Let's see what's next. Let's get a brand new color. I love my colors. And let's go ahead and divide this again. So now I've got eighths, and let's line up the pizza in a nice long pan like I did before. There's an eighth, there's an eighth, 3, 4, 5, 6, 7, 8. I'm really starting to get the feel of a parallelogram now. This is exciting. I'm excited. I hope you're excited. So I'm getting a parallelogram, and the cool thing is I know how to find the area of a parallelogram. And remember, this is just the pizza pie cut up into 8 slices. It's got the same area as it did when it was a full pie. Now, it's a bunch of little slices, but it's still got the same area. And if you can imagine cutting this into 16 and 32 and 64 and 128 and 256 and just keep doubling the number of slices, those slices are going to get really, really thin. You're going to end up with just this tiny little sliver of pizza. And when we put all those together, you're really going to get something that looks like a parallelogram. In fact, you're going to get something that looks like a rectangle. Because notice that this angle is half of the internal angle of the slice. This angle is going to be even smaller, and if I cut it into a tiny little sliver, the angle at the edge there is going to be infinitesimally small. So, imagine we've got this rectangle, and it's divided into 3,000 slices, but those slices still add up to give you the entire area of the circle. There's still the whole pizza pie just added up into a bunch of different slices. So the area should be the same. So now all we need to do is figure out the area of a rectangle, and that's really easy. That one, even if you don't remember from school, you should be able to understand, because think of it like a cake. Okay, I haven't had breakfast yet, so I'm a little hungry. That's why we're talking of pizzas, pies, and cakes. Think of it like a rectangular cake, and you're cutting it into so many slices this way and so many slices this way, and you're going to get a bunch of little rectangles or squares out of the cake. So here I have a 5 column, 3 row cake that I've cut into little rectangles, and I'm getting 15 slices. And that shouldn't be a surprise, and I doubt it is to anyone. If you've ever cut something into pieces, if you've ever divided something, if you've ever multiplied something, you know that the number of sections in the length times the number of sections in the width are going to get you the number of total sections. Alright? So let's do that here. I'm going to take the length times the width to get the area of this rectangle. Okay. I started with a unit circle, so that means that the width, the height of this rectangle, is going to be the radius 1. Great! Alright, then the width of the length of the rectangle is going to come from all of these edges. Every other sector is going to turn into an edge of the top. So if we put all those together, we're going to get half of the circumference of the circle. We're going to get pi. Alright, so this rectangle is really easy. It's just pi times the radius. Interesting. Pi times 1. The radius. But not all circles are unit circles. So let's think about if we made this a little bit bigger. Let's change my unit circle into a circle with radius r. So now that means that this sector is r, and in fact I've multiplied the entire circumference by r, so it's 2 pi r. That means that this is r, and this is half of 2 pi r, so it's just pi r. Alright, so now when I multiply these two, I get pi times r, pi r squared. Radius is the only thing we can actually change about a circle to get a different size. So by changing the radius here, by making it arbitrary, by making it anything that we can call r, we've actually made an arbitrary circle. We've actually described any possible circle by just describing 1, just giving it a funny variable name that we can change to anything we want. So if you want to know a circle with radius 5, it's 5r squared. That's all there is to it. Alright, so until next time, I hope you've enjoyed playing with geometry with me. I've been your naughty professor, and I will be as long as you want me.